stop. That means it's recording now. Okay? So we are rationalizing the denominator today, and just like you can't have negative exponents, you also cannot have radicals in the denominator of a fraction. It's not considered simple if that's the case. So what we do is we multiply these by 1. And remember, the multiplicative identity says that we can multiply any number by 1 without changing the value of the number. So we're going to multiply this by a 1, and the one that we're going to pick is kind of a magic one because it's going to miraculously get rid of the radical. So when we multiply this, the square root of x, and this becomes x squared, and now we know that the square root of x squared is just x. So this simplifies to be the square root of x over x. And the even odd rule doesn't apply here because we go back to the original problem, even, odd, so it doesn't need to have an absolute value. Always go back to the original problem to see if you need absolute value. So again, our goal here was to make sure there was a radical in the bottom. So we picked a 1 that would allow us to not have a radical in the bottom. And the one that we picked was kind of magical because this value is 1. And a lot of people have a little trouble deciding what one to pick. And the way you decide that is if it's a monomial, if you are dealing with a monomial in the denominator, then the magic one is that monomial over itself. Okay? In just a moment, we're going to pick a binomial in the bottom, and there's a different rule, not really a different rule, but kind of a different step to do with that one. So the goal here was to make sure there's no numerator, no radical in the denominator, and that's what we did. Now, many of you are headed to calculus, and some occasions you might be asked to rationalize the numerator when we're doing derivatives. So you would do that the same way. You would just pick what was in the top to be your magic one. So here's a second example, and I picked this one because it has a radical in the numerator and a radical in the denominator. We're still going to multiply this by 1, and the one that we're going to pick is the square root of 6x over the square root of 6x, the square root of 6x, because it's a monomial again. Monomial simply means there's no adding and subtracting in the bottom. There's one term in the bottom. Okay? So remember, when you multiply square roots, you do outside times outside and inside times inside. So this turns out to be the square root of 12x over 6 times 6 is 36. X times x, so this would be 36x squared. And when we bring it out of the radical, it's just 6x. Now, we still have to simplify these radicals because we might be able to reduce them. So we know that 12 can be factored. So 12 is 2 times 2 times 3 times x over 6x. And the 2 is going to come outside the radical. So it's going to be 2 square roots of 3x. Now, it might be tempting to cancel the 6 and the 3, or the x and the x, but you can't cancel if it's under the radical. 36x squared, the square root of 36 is 6.
Oh, so that's going to square root.
Right, so I just simplified that pretty quickly, kind of jumped over it. So thank you. This times this is 36x squared, and then I square rooted it to get this. Okay? Now, back to this. It's tempting, I know, to cancel the 3 and the 6 and the x and the x, but these are under the radical. You can never cancel things under the radical. However, the outside of the radical, this is really 2 6 times the square root of 3x over x. 2 6 can be reduced, can it? It's 1/3. So the answer, the simple answer is the square root of 3x over 3x. Okay? And remember, this 3x can't cancel. The one on the top cannot cancel with the one on the bottom. Okay? You can't cancel this 3x with this 3x because this one's inside and this one's outside. Question number 3. You still have to rationalize because you're not allowed to have a radical in the denominator. The difference in the first two examples and this one is this is what we call a binomial. A binomial means that it has two terms in the bottom. And terms, remember, are separated by plus or minus. So in the first two examples, we had one term. In this example, we have two terms. And we still multiply by 1, but we select the 1 a little differently. We have to think about what will make the middle term cancel. And so we think back to that idea of a squared minus b squared, and that factors into a minus b, a plus b. And so you remember from Algebra 2, that is called the difference of squares. And so what happens when you multiply FOIL, this difference of squares, is that the middle terms cancel out. So we're going to pick the other one. In this particular question, we have plus. So the magic 1 is going to be 3 minus the square root of 11 over 3 minus the square root of 11. And it's still 1, so we're not changing the value of this, but it is a binomial. And we've given this in mathematics, we've given this a name. It's called the conjugate. A conjugate is a binomial term that matches term for term, and it has a minus if you start with a plus, and a plus if you start with a minus. So if you think of the conjugate, that's what we're going to talk about. So the conjugate of 3 plus the square root of 11 is 3 minus the square root of 11. And so when you have a binomial, the conjugate helps you to pick the magic 1. Because look what happens now. As we multiply these, we're going to do 13 times 3 is 39. And 13 times the square root of 11, this is an outside number, so we're going to leave it outside. So it's 13 square roots of 11. This one has no inside term, so we can pretend that the inside term is 1. So when I multiply a constant by a binomial, I should get a binomial, right? Now this I have to FOIL. You remember first, outer, inner, last? So 3 times 3 is 9. 3 times the negative square root of 11 is minus 3 square roots of 11 because 3 is outside and 11 is inside, so they stay there. Plus 3 square roots of 11. Okay, and now, and here's what we had a question about a little earlier. This is really the square root of 121 because 11 times 11 is 121. But isn't that just 11? So we're going to write that as 11, and the 9 is going to stay down there. What happens to the middle terms here? Isn't the square root of 3 square roots of 11 negative? Plus 3 square roots of 11 is going to cancel out. Isn't that 0 using the added inverse property? So there is no more radical on the bottom. The radicals all canceled out. That was our goal. If there's a radical on the bottom, you picked the wrong conjugate. Okay? So on the top now, we have 39 minus 13 square roots of 11. And on the bottom, we have 2. So some people factor this. These have a common factor of 13, so they would keep this as 13 times 3 minus the square root of 11 to see if you could cancel here. But this is not going to cancel with a negative 2.
There's a line there.
Because the square root of 121 is 11. Okay. Let's see if we can get this one done. The conjugate for this one is the square root of 5 minus the square root of 11 over the square root of 5 minus the square root of 11. So what happens in this one is that we have to FOIL both the top and the bottom. And in the first one, we just had to distribute. So in example number 3, you distributed the 13. Here you have to FOIL. So 1 times the square root of 5 is the square root of 5. And 1 times the square root of 11 is the square root of 11. And the square root of 5 times the square root of 5 turns out to be 5, correct? Can I make that jump? And the square root of 5 times the square root of 11 is the square root of 55, because they're both inside numbers. So you do multiply them. Okay? And on the bottom, this one's going to be the square root of 5 times the square root of 5 is 5. The square root of 5 times the square root of 11 is minus the square root of 55. This is going to be plus the square root of 55, so our middle terms cancel out again, don't they? And the square root of 11 times the square root of 11 is the square root of 11. Square root of 121. Okay, so I skipped a couple of steps there because I thought you were ready for that. These terms cancel because they're opposite. Like terms are a problem up here because these terms are not alike, are they? Okay? So they have to stay separate when they're not alike. So the numerator is not going to look very pretty, but it's not going to have any radicals in the denominator. 5 minus 11 is negative 6. And I can rearrange this a bit so that the constant comes first, which is called standard form, but not really necessary because none of these terms are alike, and none of these can be simplified either. You might think that you could factor the 55, but 5 and 11 are both prime, so it's not going to have anything out of the radical. And so that does it for rationalizing the denominator.